serdecznie. To dla mnie wielki zaszczyt i przyjemność przywitać Państwa na Katolickim Uniwersytecie Lubelskim Jana Pawła II, który jest lokalnym organizatorem 11. Zlotu Filozoficznego. I to jest też moja przyjemność przedstawić Państwu panią dziekan, panią profesor Monikę Walczak, która otworzy oficjalnie ten zlot za chwilę. Ladies and gentlemen, this is a great honor and a pleasure for me to welcome you at the John Paul II Catholic University of Lublin, which is the host of the 11th Philosophers' Reign. And this is my pleasure to introduce to you Professor Monika Walczak, the Dean of our department, who will officially open the conference. Mrs. Dean, please.
Dzień dobry Państwu. Good morning everyone. Miło mi powitać Państwa na 11. Zlocie filozoficznym odbywającym się w dniach 2 i 4 lipca 2015 roku na Wydziale Filozofii KUL. I'm very pleased to welcome you at the 11th Philosophers' Rally that is held from July 2nd to 4th, 2015 at the Faculty of Philosophy at the John Paul II Catholic University of Lublin. Cieszę się, że młodzi filozofowie i adepci filozofii dostrzegli w zlocie miejsce, gdzie mogą zaprezentować swoje przemyślenia, podyskutować i, co zawsze ważne na konferencji, nawiązać intelektualne, no i mam nadzieję, że nie tylko intelektualne, kontakty i przyjaźnie. Jestem pod ogromnym wrażeniem bogactwa problematyki zaprezentowanej przez Państwa w księdze abstrakcji Zlotu. Świadczy ona o tym, że problematyka filozoficzna jest żywa i świeża i dobrze wróży filozofii. I am glad that young philosophers recognize the rally as a good place to present our research, to discuss, and what is always important, to establish intellectual, and I hope not only intellectual, relationships and friendship. I'm very impressed to multiplicity and diversity presented by the book of abstracts for this conference. It indicates that philosophical problems are live and fresh, and it is a great hope for philosophy. Zlot gościł już wcześniej w Lublinie, m.in. w Kulu w 2004 roku, wtedy jeszcze jako forum filozoficzne. Lublin and the John Paul II Catholic University of Lublin have already had the honor to host the Philosophers' Rally in 2004 under the name of the Philosophical Forum. Organizatorami tegorocznego zlotu jest Wydział Filozofii KUL oraz Ośrodek Badań Filozoficznych. Głównym sponsorem konferencji jest Ministerstwo Nauki i Szkolnictwa Wyższego. Zlot odbywa się pod patronatem Komitetu Nauk Filozoficznych PAN, Polskiego Towarzystwa Semiotycznego, portalu Akademikon, czasopisma Filozofii oraz Radia Lublin. The Faculty of Philosophy at KUL and the Center of Philosophical Research are organizers of this year's rally. Ministry of Science and Higher Education is a main sponsor of the conference. The rally is held under the auspices of Committee of Philosophy at Polish Academy of Sciences, Polish Semiotic Society, a portal Akademikon, a journal Filozofii and Radio Lublin. Witam bardzo serdecznie zaproszonych na zlot gości, którzy wygłoszą referaty plenarne. Profesora Anjana Chakravartty z University of Lublin. Welcome, professor. Profesora Stanisława Lubickiego z Uniwersytetu Gdańskiego. Profesor Katarzyna Kijania-Placek z Uniwersytetu Jagiellońskiego. Profesora Dariusza Łukasiewicza, bo jeszcze go nie ma, z Uniwersytetu Kazimierza Wielkiego w Bydgoszczy. Profesora Tomasza z Uniwersytetu Warszawskiego. Welcome Dr. David Ludwig from the University of Amsterdam. Welcome Dr. Christian Wallman from the University of Kent. Witam także pana magistra Jacka Wawra z Uniwersytetu Jagiellońskiego i doktora Marcina Iwańskiego z naszego uniwersytetu. Witam wszystkich uczestników Zlotu, którzy współtworzą konferencję, wygłaszając referaty. Witam także wszystkich uczestników konferencji, którzy biorą w niej udział, po prostu czyniąc zadość swoim filozoficznym zainteresowaniom. I welcome all participants of the rally who contribute to the conference with their talks. I welcome also all participants of the rally that are here because of their philosophical interests. W trakcie obecnej edycji Zlotu wygłoszonych zostanie 147 referatów, w tym 52 referaty w języku angielskim. Uczestnicy konferencji reprezentują 38 ośrodków z 12 krajów. During the conference, you can listen 147 papers, including 52 talks in English. The participants represent 38 universities and schools from 12 countries. Dziękuję bardzo i gratuluję organizatorom bogatych problematykę i bardzo ciekawie zapowiadającej się konferencji. Dziękuję organizatorom Zlotu z ramienia Ośrodka Badań Filozoficznych, panu profesorowi Tadeuszowi Cieciewskiemu, panu doktorowi Pawłowi Grabarczykowi i doktorowi Witoldowi Hanslowi. Z ramienia Wydziału Filozofii organizatorami Zlotu są dr Piotr Lipski, któremu bardzo serdecznie dziękuję, bo to na nim największy ciężar organizacyjny spoczywał. Profesor Paweł Kawalec, oraz doktoranci Wydziału Filozofii, pan magister Błażej Kępura, pan magister Adam Bubiak i pan magister Rafał Łodzisz. Congratulations to organizers of the conference that looks very promising because of the diversity and interesting topics of papers. I would like to give thanks to some people for organizing this conference. Special thanks are due to organizers of the rally from the Center of Philosophical Research, Professor Tadeusz Cieciewski, Dr. Paweł Grabarczyk and Dr. Witold Hensel, and to organizers from the Faculty of Philosophy at Hull. I list them once again: Dr. Piotr Lipski, Professor Paweł Kawalec, and doctoral students, Magister Błażej Kępura, Adam Kubiak and Rafał Łodzisz. Dziękuję także następującym doktorantom i studentom Wydziału Filozofii Kult, którzy zaangażowali się bardzo mocno w przygotowanie Zlotu. Panu magistrowi Piotrowi Wilgorejskiemu, pani magister Monice Wylińskiej, pani magister Marii Kubiak, panu magistrowi Michałowi Tatarczakowi, pani licencjat Justynie Kurlak i pani licencjat Paulinie Wiejak. Wyrażam wreszcie ogromne podziękowanie Ministerstwu Nauki i Szkolnictwa Wyższego, które wspiera i sponsoruje tę konferencję. I would like also to express a great thanks to Polish Ministry of Science and Higher Education as a sponsor of our conference. Szanowni Państwo, jestem przekonana, że referaty i dyskusje, które będą miały miejsce w trakcie tej konferencji, dostarczą Państwu inspirującej pożywki do przemyśleń i okazji do rozwijania swoich badań. Otwieram 11. Zlot Filozoficzny i życzę Państwu ciekawych i owocnych obrad. Ladies and gentlemen, I am deeply convinced that papers and discussions performed during the rally give you inspiring fresh insights and opportunities to develop your research. I am opening now the 11th Philosophers' Rally, and I wish you interesting and fruitful talks and discussions. Thank you very much.
Center for Philosophical Research, main organizer, being the less important one, because the really important organizers are people from the Catholic University of Lublin. So let me take a moment to just thank you very much for the great job you're doing, guys. Thank you. And I'm here to introduce our first speaker, Professor Anjan Chakravartty from the University of Notre Dame, Indiana. He's the director of the John Riley Center for Science, Technology, and Values, editor-in-chief of Studies in History and Philosophy of Science, and author of the book A Metaphysics for Scientific Realism, Knowing the Unobservable, published by Cambridge University Press in 2007, for which he received the Canadian Philosophical Association Book Prize in 2009. He is a philosopher of science, as you probably know. Really needs no introduction, I think. But he has a bachelor's degree in biophysics. He actually started his career as a biophysicist. Then he went to Calcutta for 3 years to do some very exciting work, and switched to philosophy. He obtained his PhD from the University of Cambridge, and now he's here with us. Professor?
Thank you very much, Vitek, for that very kind introduction. And let me just reiterate what people have already said about how much work has gone into this conference. I wanted to add my voice to thanking everybody who's been involved on the organizing committee and otherwise to bring this about. We all know just how much work it is to organize an event of this magnitude. It's a huge amount of work. And looking at the program, looking at the few days ahead of us, it looks as though it's going to be a fantastic few days. So again, many thanks to everyone who's involved in organizing that. And also, I'd like to just say thank you very much to everyone who's here, who's come from far and wide. I know that some people have come from far away, and it's really nice to be part of this. I feel personally honored and gratified to have been invited to kick things off here at the Philosophers Rally. I know that the event has a wonderful recent history. I'm really looking forward to doing some good philosophy with everyone over the next few days. I'm especially excited because I know that while the theme here is philosophy, I understand from talking to various people that one of the intentions of the conference has always been to involve people who are interested in philosophy but are maybe coming to it from allied disciplines in the humanities or in the sciences. And as Vitek said, I'm a philosopher of science. Philosophy of science is by its nature highly interdisciplinary, so it would be really nice, I think, to be able to talk about philosophy with people whose daily preoccupations might extend beyond philosophy, and that's as it should be. And just on one last personal note, I just wanted to say that this is the first time I've been to Lublin. I've been to Krakow, I've been to Warsaw, I've been to Wrocław, but never before here. And I just have to say that it's a beautiful place. It really is wonderful. And so, again, it's really lovely to be here. So thank you very much. So, let me begin. The title of my talk is Fundamental Entities and the Ontology of Properties. But I'm sure it hasn't escaped your notice that there are lots of ways that one might actually approach the issues of fundamental stuff on the one hand, and property identity on the other hand. And I have some fairly specific things in mind here to discuss today. So I want to take a few minutes just to give you some background regarding the issues that I'm going to be thinking about, or that I have been thinking about this past little while. And hopefully that will give you a clearer picture of the specific way that I'm going to be engaging with the topics of fundamental entities and property ontology. Now, some of you may have noticed with approval or disapproval, depending on how you see these things, an impressive wave of recent work in the so-called metaphysics of science. The idea of a lot of this work is to take some of our best science seriously as a basis for, or as a kind of constraint on, work in metaphysics, and in ontology more specifically. Now, my own interest in this area began some years ago with an attempt to defend the view of scientific realism. So for those of you who aren't philosophers of science, scientific realism is basically the view that our best scientific theories are true, or at least approximately true. That is, they're telling us the truth, or something close to the truth, about the nature of the world out there, a kind of mind-independent reality. If you don't like truth talk, you can describe this in terms of our theories telling us about things in such a way as to refer to things that are in this world. If you don't like talk of reference, you can talk about different ways of parsing realism, but the basic idea is that it's a positive epistemic attitude towards the outputs of our best science. Now, as it happens, this was really kind of stepping or springboard for me to think about some issues of the metaphysics of science. And in the course of doing some of this work on scientific realism, I realized that it was probably going to be important to give a clear picture of some of the central metaphysical underpinnings of the view, in order to have a decent understanding of what it is that scientific realists are aiming to be realists about exactly. So, for example, in the book that I wrote a few years ago that Vitek just mentioned, I attempt to spell out a unified account of scientific properties, of causation, laws of nature, and kinds, natural kinds, because I take those concepts to be the most important metaphysical presuppositions of the version of realism that I wanted to argue for in the book, which I call semi-realism. And it just so happens that the most economical and compelling way to unify all of those things, at least that's what I argue, is with an ontology of dispositional properties, or causal powers. The idea of causal powers and the modern concepts in terms of which they're commonly discussed, so you hear terms discussed such as capacities, dispositions, propensities, tendencies, all of these sorts of concepts have been discussed in a lot of recent philosophy of science. I'm simply going to use the term disposition from here on in. If something has a disposition, it has the power to behave in certain ways under certain kinds of circumstances. And it does. So if you put some salt in a glass of water, it dissolves. It has the capacity or the disposition of solubility. The most obvious argument in favor of a realism about dispositions is that by positing their existence, we gain some sort of explanatory power. So why is it that objects that share properties have the same sorts of causal relations? Why are most of the objects of our everyday experience likely to behave in highly similar ways in sufficiently similar counterfactual circumstances? What grounds the regularities that we describe in terms of laws of nature? Well, answers to those sorts of questions given by neo-Aristotelian dispositional realists appeal to explanatory power, right? If there were such things as dispositions, that would provide explanations of the relevant phenomena that I just mentioned. Explanations that would be lacking otherwise. And this is suggested as a reason for thinking that they exist. On the other hand, the neo-Humean tradition is typified by a rejection of these sorts of explanations. It would be better, they might say, to have no explanations of these phenomena at all than to have explanations in terms of an ontology of dispositions. I mean, after all, Hume would say, there just are no necessary connections between distinct things in the way that dispositions suggest. And of course, isn't the idea, the very idea of a disposition, a little too mysterious or perhaps a little too spooky to serve as an explanation of anything, right? What is a causal power? Now, the sorts of arguments that I just alluded to between certain kinds of metaphysicians and certain kinds of empiricists have really echoed through the history of philosophy. And it isn't my intention here to go through all of those traditional arguments yet again. I wanted to mention it as part of the background for things that I do want to talk about today. What I do want to look at very specifically is a part of science, the so-called standard model of fundamental physics, which several people have argued recently is really not well described in terms of an ontology of dispositions. So we have a kind of rift in the literature. Some people wanting to think about fundamental properties of things in physics in terms of a dispositional ontology, and various other people who'd like to resist that idea. And among the resistors, what they say is that the theory, the standard model in fundamental physics, describes the relevant properties simply as invariants of symmetries. And that once we understand this properly, you'll see that the best way to view the ontology of these properties is really not in terms of dispositions after all. Now, I'm going to have some more to say about symmetries a little bit later on, but let me just give you the intuitive gist of the idea here in passing. Just for those of you who happily waved goodbye to physics a long time ago. So a symmetry is a transformation, or a group of transformations, of an object or of a theory, in which certain features of those things are unchanged. That is, the relevant features are preserved, they remain invariant under the transformation. So just to take an intuitive example on your handout, which I hope everyone has a copy of, I've drawn a square. Now, imagine rotating that square clockwise by 90 degrees. The result is a square. Now, imagine a different kind of transformation. That transformation maps the square onto itself. The feature of squareness is invariant under the transformation of rotating it by 90 degrees. On the other hand, imagine rotating the square clockwise by, say, 45 degrees. The result is a diamond. And so we've mapped a square onto a diamond. So squareness isn't invariant under that kind of transformation. Admittedly, this is an intuitive and not actually a great illustration, because you might think that the shape is actually invariant under that kind of rotation. So I'm asking you to imagine that you're playing cards or something, right? Where a diamond is really something, and a square is really not. Or perhaps a better example would be, I could have talked about rotation, and instead of talking about shape, I could have talked about height. When you rotate that square by 45 degrees, the height of that figure is different, right? Because we know that the diagonal from one vertex to an opposite vertex is greater than the size of one of the sides. So that might be a better example. The kinds of transformations that are discussed in fundamental physics take a lot of different forms. So you might transform something spatio-temporally, right, by translating it in space or in time or in space-time. You might rotate it in just the way that I've described. You might change the phase of its wave function. Depending on which variables are involved in the transformation, they're classified in different ways. And I'm not going to worry about those details here today. The only other thing that I think will be useful to keep in mind for the purposes of today is the concept of a group. So, in any given case, the collection or group of transformations that leaves something invariant is what we call a symmetry. Now, a number of people have argued that once we appreciate the kind of work that symmetries do in physics, we'll see that thinking about the properties of fundamental physical things as dispositions is at best uncalled for, and at worst kind of problematic. So my plan for today is the following. In the next section, I'm going to review the challenges to dispositionalism that thinking about symmetries has generated. And then what I'm going to do is argue that these worries turn out to be not so worrying after all. After that, I'm going to examine the supposed alternative that thinking about symmetries is actually supposed to give us. And I'm going to suggest that the imagined advantages here, it turns out, are kind of imaginary. So in conclusion, I'm going to reflect a little bit on what I think is going on here in this debate, or this dialectic, by saying a few words about the different stances that a disposition-based versus a symmetry-based approach to fundamental physics actually gives us. And I'm going to diagnose this difference in terms of a difference in kinds of explanation. But more on that soon enough. So that was all by way of background. Let me now dig in to the main content of what I wanted to say today. What's so terribly wrong with thinking about properties like the mass, or the charge, or the spin, which is a sort of intrinsic angular momentum? What's so wrong about thinking about these properties of, say, subatomic particles as being dispositional in nature? Well, I think two main concerns have surfaced. The first appears nicely in a recent paper by Vasilios Lavanios, but it raises some larger issues that I think have been floating around for quite some time and have been raised by people like Stephen French, among others. So I'm going to call this the argument from structural description. Lavanios' target is dispositional essentialism about properties. Dispositional essentialism is the idea that what makes a property the property that it is simply the dispositions that are associated with it. And here's what he says about this. Here's a quotation that's on your handout. If the identity of the fundamental physical properties can be provided by symmetry considerations, why can't we claim that being invariant under the action of fundamental symmetries is an essential feature of the fundamental physical properties? Anyway. So the idea here is that being invariant under certain symmetry group transformations is itself a non-dispositional kind of thing. But that, I think, is rather difficult to understand. I mean, first off, note that the action of a symmetry is described mathematically. Presumably the intention here is not to say that a mathematical description, that is, a linguistic entity, is part of the essence of something in the world. I mean, that would be to conflate descriptions of things with the things that they're actually supposed to describe. So the point here must be that symmetries themselves are things in the world. They are part of the ontology of the world, and thus conceived they're part of the essences of these fundamental properties. But now this sounds a lot like dispositional essentialism. Because symmetries are transformations with invariance. They describe how things with certain features, one might call them properties, are apt to behave in a variety of circumstances. Well, that just sounds like disposition talk. So I think that there's something self-defeating here in the attempt to make symmetries in the world part of the essence of fundamental physical properties, in hopes of introducing something non-dispositional, a non-dispositional element. Because thus conceived, right, not merely as descriptions, which of course any good Humean could happily accept, but rather as a group of potential transformations, they seem to grant the dispositionalist everything that she might want. Okay, let me move on to the second concern about disposition that's offered by those who would like to champion symmetries instead. And this concern, I think, has a very long-standing and important pedigree. I'm going to call it the argument from conservation laws. So some of you may know that Emmy Noether is famous for a theorem that she proved in 1915 that says that for every one of a certain class, a certain group of symmetries, there's a corresponding conserved quantity, and vice versa. So quantities like mass energy, electric charge, spin, momentum, all of these quantities are conserved quantities. That is, they remain constant in so-called closed systems. Now many people, including some friends of dispositions, have worried about whether dispositionalism is actually compatible with the idea that there are conservation laws. But for example, Alexander Bird, I think I've given you this quotation as well, says that, quote, "It is difficult to see why, for example, when two charged objects interact, it is a manifestation of the dispositional essence that the total charge should remain constant." So why is it that when you have these two things that each have their own charge, when they interact, the overall charge of the whole system should remain constant? He says that's hard to understand in terms of just the dispositions of these two things themselves. And recently, Stephen French has exploited this sort of worry in arguing against dispositions. He doesn't really like Bird's own response to this concern. Bird says that, well, maybe we should just view conservation laws as mere pseudo-laws that physics will ultimately get rid of, throw in the garbage. I have to agree with French. I think that would be a pretty desperate thing to say. But there's another way forward here, which, as it happens, I don't think anyone really likes, except for John Bigelow, Brian Ellis, and Carolyn Lierz, and actually perhaps me. Why not think of the relevant dispositions regarding the conservation of certain quantities as properties of systems of things, as opposed to properties of the things that compose or inhabit these systems? That's what Bigelow, Ellis, and Lierz had in mind in a famous paper that they wrote in 1992, where they suggested that the world itself is a member of a natural kind, and that symmetry principles and conservation laws are just part of the essence of that kind. Now, that may sound like a very grand claim, right? In fact, when I read that paper the first time, I actually thought that it was a fairly desperate maneuver. And I think that that's a popular view. It's certainly one that's, I think, shared by Bird and French and Levanios, surely among others. The worry here is that that kind of move, saying that these things are just features of the natural kind, and the world is a member of that natural kind, the worry is that that kind of move is ad hoc, because it's made simply to square the idea of conservation laws with dispositions. So Bird himself actually only likes to talk about the essences of properties, not kinds. So he prefers the formulation of this idea on which it's the property of being a world of this kind that has the relevant essence. But of course, it's no less ad hoc if you formulate it that way. Levanios adds that he also thinks it's just a bad explanation. It's a poor explanation, presumably because it's empty or uninformative to say that the world behaves in a certain way because it has a world property. It doesn't seem to be telling you very much. On reflection, though, I don't think that all of these people, including my former self, are right about that kind of concern. I mean, after all, we experiment on and we theorize about different kinds of systems. And it's an empirical discovery that certain quantities appear to be conserved in systems that are appropriately closed with respect to those quantities. So when we find that empirically, then in good dispositionalist form, we say that that's the nature of those systems. They're disposed to behave in that way. And it just so happens that the world as a whole is trivially a system of the relevant type, just because, once you're considering the world as a whole, there's really nothing else with respect to which it could be open. Well then, so be it. Why should that be a problem? So I don't think that this maneuver is ad hoc. I think the notion of a closed system isn't an empty or a physically trivial concept. It's actually a physically substantive concept. Bird has one last worry up his sleeve, but I don't think that it's compelling either. He thinks that because a disposition for conservation would be a property of an ensemble of things, a group of things, rather than the things themselves. Here's a quote. He says, "It seems to be a macro property that is an implausible candidate for being fundamental." Now, it isn't a foregone conclusion that non-fundamental things can't have dispositions. I don't actually see why I couldn't myself, but just for the sake of argument, let's grant this to Bird. I mean, I can see the attraction of having a sparse or very economical view of properties. So let's grant Bird the stipulation merely for the sake of argument. Let's say that non-fundamental things don't have dispositions. Even granting that, it isn't obvious to me that an ensemble can't be fundamental in the appropriate sense. If it has properties that aren't reducible to the properties of its parts. And it seems to me that that's exactly what we appear to have in the case of closed systems and period dispositions for conserved quantities. So just to give you an example of a contrast, what I don't have in mind, I mean, here's a case where you might argue that a property of an ensemble of things isn't fundamental. I have a mass, and that mass my mass isn't really a fundamental property of me, because each of my subatomic parts, constituents, also has a mass. And the sum of all of those masses just is my mass. So if you were to contemplate all of their dispositions to be accelerated under applied forces instead, then perhaps we'd see that my apparent disposition to accelerate really isn't fundamental after all. Now, when it comes to the fundamental properties, Bird says this, quote, "Properties are already constrained by their own essences, and so there is neither need nor opportunity for higher order properties to direct which relations they can engage in." End quote. Well, that's wrong. Right? We know that to be false for certain kinds of systems. So, for example, anyone who's ever read a popular science article about quantum theory will have come across the idea of entangled systems. Systems of particles in the so-called singlet state, for example. Our best physics and lots of experimental results establishing the violation of something called Bell inequalities tells us that these systems have properties that can't be reduced to the properties of the particles that make them up, taken individually. In cases like this, I really don't see anything wrong with saying that the system itself has properties that are fundamental, in the sense that they can't be decomposed into or reduced into the properties of their parts. Now, for those of you who haven't actually read a popular science article on quantum theory, here's another putative example of the properties of the system constraining the behaviors of its parts. And this is a classic example from Alan Garfinkel. He talks about something that you may have come across before, the Lotka-Volterra model, which is a model that's been used in application to lots of different kinds of phenomena. It's very broadly applicable. It's basically just a pair of first-order nonlinear differential equations that are used to model the dynamics of certain kinds of systems. And what these equations describe are a couple of curves that are sort of like sinusoidal curves. And Garfinkel talks about them in application to looking at predator-prey systems. So he talks about a certain forest where there's a population of foxes and there's a population of rabbits. Right? As conditions favor the rabbits, their population increases. Right? As there are more and more rabbits that are abundant, then the foxes have more to eat, so their population increases. At a certain point, there are just going to be too many foxes for the rabbits to handle, and so their population will start to go down. As the food supply goes down, the foxes won't have enough to eat, so their population will go down. So you have this pair of curves that just kind of follow one another in time, right, of the populations of these two groups of organisms. Now, Garfinkel argues that sometimes there are facts about things that just can't be explained in terms of the properties of individual foxes and rabbits. So he says that there are facts about things like the death of Peter the rabbit that just aren't well explained by the properties of individual foxes and rabbits, but that are well explained by structural properties of ensembles of populations of foxes and rabbits. I mean, in a given case, say, Peter was killed by an individual fox, but if that one hadn't got him, then he very likely would have died anyway, just because of certain facts about the population, the density, and the distribution of foxes. Right? Maybe there was just a lot of them around. So the fact that Peter was killed by a particular fox is really kind of neither here nor there. Right? He's going to die anyway. The relevant explanatory facts here are higher level facts about system level properties. There's more to be said about these kinds of examples, I think, but for now, what I want to do is move on from a consideration of arguments against dispositional properties stemming from symmetry considerations. And I want to turn to arguments for a different kind of understanding of the nature of fundamental properties, and that's based on symmetries. All right, so what's the alternative here? There's an underlying theme in the work of people who champion a symmetry-based approach to understanding properties in physics. And it goes this way. Symmetries give us an understanding of the natures of properties that's less ontologically inflationary than the dispositional field. Thus, as far as a kind of cost-benefit analysis goes, it's preferable just because it's simpler. What I want to do now is to dispute that idea. On careful reflection, I think, it turns out that the symmetry-based view isn't any more austere, ontologically, than the dispositional view. And so we shouldn't really prefer one over the other just based on considerations of simplicity, sort of Occam's razor type considerations, all by themselves. The claims here by symmetry theorists, again, take two basic forms, so I'm going to consider them in turn. The first is that, armed with symmetries, we can understand the natures of properties without bringing the idea of causal properties or causal roles and hence dispositions into the picture at all. And so we can have an ontologically simpler picture of what those things are. Symmetry principles, as represented mathematically using group theory, beautifully describe the differences between the things that make up the sort of zoo of particles in the standard model in fundamental physics. So here we have a mathematical apparatus, these transformations and invariants, and the symmetry principles describe and distinguish different particles from one another based on those. So to take some examples, just in case there are any closet philosophers of physics here, for those of you who are into this sort of thing, mass and spin can be defined as eigenvalues of the Casimir operators of the relevant symmetry group, the Galilei group in non-relativistic physics, and the Poincaré group in the relativistic case. That is, as invariants of the relevant groups. Quantum charges can be defined in terms of the generators of certain quantum gauge groups. For example, U1 for electric charge. Now, if that doesn't mean anything to you, don't worry, right? It doesn't matter. The point of all of this is just that you might think that here we have a purely mathematical, theoretical apparatus for describing the natures of the properties in the world. And therefore, it simply isn't necessary to appeal to the causal roles of things in the form of their dispositional properties in order to understand their natures. That's the basic idea. So for example, Debanios thinks that we can identify properties simply by examining these symmetries in the theory. You might think, he says, that what these symmetry considerations are giving us is information regarding the causal behaviors of things. The causal behaviors of things that have these properties. But really, examining symmetries is, and here I quote, and this again is on your handout, examining symmetries is a purely conceptual way of finding the invariance of certain transformations. Hence, insofar as we do not have to measure anything in order to find the invariance, in the case of mass, charge, etc., it is plausible to claim that the suggested identification is independent of any causal roles. End quote. But is it really independent of any causal roles? I don't think so. In fact, I would say that we don't identify anything in the world merely by examining symmetries. All that examining symmetries can do is provide us with descriptions of candidate properties that are then put to the test of experiment. So I'm reminded here, when I think about this, of a nice paper by colleagues Murado Dorota and Laura Farina on structural explanations in quantum mechanics. The idea in this paper is that various things can be explained on the basis of purely formal or mathematical aspects of the theory. But they add a crucial kind of caveat. They say, in order to have genuine content, these aspects have to be taken to represent or to refer to something in the world. Otherwise, they're not explaining anything. Right? So you can have a purely formal or mathematical explanation, but unless the relevant terms of the explanation are latching on to something in the world, then they're not really giving you anything in terms of genuine explanation. And I think it's a failure to pay attention to that caveat that dooms the idea that you can identify fundamental physical properties simply by examining symmetries. So let me just illustrate this with the example of what's called permutation invariance. In modern-day quantum theory, unlike in classical physics we associate with Newton and so on, in modern-day theory, permuting particles of the same sort, that is, swapping them around, right, changing them around with respect to one another, doesn't actually count as a new physical state of affairs. Right? That seems strange to us. two balls and you think about them classically, if you switch their positions, well, now we have a new physical arrangement, right? One in which we switch them. In quantum theory, if you take two particles of the same type and you swap them around, that doesn't actually count as a new physical arrangement, given the kinds of statistics that we use to describe these states of affairs. In the technical lingo, again, just for those of you who are interested, group theory enters here in the form of a relationship between what are called irreducible representations of the permutation group and subspaces of the Hilbert space that represent states of the system. So the representations correspond to mutually orthogonal subspaces in the Hilbert space. And again, for those of you who aren't closet physicists, the important point is just this, and this is something that French knows. The mathematical description here gives us different representations. So we have what are called symmetric or bosonic representations. Those are the bosons, that's one kind of particle. And we have antisymmetric or fermionic representations. Those are for fermions, that's another kind of particle. And they correspond to the kinds of statistics that we use for counting them. So in the case of bosons, we use what are called Bose-Einstein statistics. In the case of fermions, we use what are called Fermi-Dirac statistics. Here's the catch. There are a whole bunch of so-called paraparticle representations in the theory that correspond to so-called parastatistics. So far as we can tell, there are no paraparticles in the world. That is, so far as empirical science has revealed, there are no such things. Now, to be fair, colleague Weston Lenovo told me the other day that there was a recent experiment that was conducted to actually test this hypothesis. But I think that just goes to prove my point, right? And my point is this. Here, there really is no choice but to think about properties in the world as things that have causal roles, and that consequently are amenable to experimental testing and probing and measurement. And this plays right into the dispositionalist's hands because she can explain what's going on in circumstances like these. She would say, things like electrons have dispositions to behave in the ways that are described by, in the theory, it's called the antisymmetric representation of the permutation group. That's why we get the results we get when we experiment on them. The paraparticle representations, however, would appear to be just surplus structure in the theory. Right? They don't refer to anything in the world. I want to return now to the second argument that I hinted at a moment ago for the relative ontological simplicity of symmetry-based views of fundamental properties. And this argument is due primarily to French. So in his view, and this is part of his advocacy of a position that's become quite famous in the literature, ontic structural realism, the symmetries themselves are part of the furniture of the world. That is to say that they aren't merely mathematical descriptions or aspects of the theory. Rather, they're mathematical structures that have been reified as ontologically subsistent things. This, he thinks, will allow us to make room for causation without having to bring dispositions into the picture at all. Now, there are various aspects of this philosophical view that you might want to take issue with. So, for example, a number of people, including Matteo Morganti in a recent book called Combining Science and Metaphysics, wonders what it could mean to take seemingly formal, abstract things like invariants and symmetries and make properties and objects out of them. I think this, in a nutshell, is really just the tip of the iceberg of a collection of worries that people, a number of people, including myself in some past work, have had about the idea of ontic structural realism very generally, and about symmetry relations in particular. Right? Worries about whether we can actually make sense of the idea that the relevant mathematical relations are in some sense concrete, not merely abstract objects, but they're in the physical world somehow. Quantum physics doesn't entail or even suggest all by itself that symmetries should be interpreted ontologically. But for the sake of argument here, again, let's grant that that's a coherent idea, and ask what follows regarding the view that the symmetry-based approach is ontologically more parsimonious or simpler than than a dispositional understanding of properties. You know, if you don't think that a reification of symmetries as part of the furniture of the physical world involves some significant metaphysical inflation, then you should probably ask a Humean or a regularity theorist about laws, or a constructive empiricist, or for that matter, anyone who views laws and symmetries as descriptions of the world, not as parts of the world, whether he or she agrees with you. I think they probably wouldn't. French maintains that not only are symmetry principles beautiful descriptions of differences between things described by the standard model, but that they're also things that exist in the world and then somehow explain the diversity of particles and their properties that we find in the world. So let's agree to reify these symmetries for the sake of argument. So we're going to say that the mathematical apparatus of transformations and invariants has been reified. What sort of an explanation or understanding of properties would that yield? I mean, how would these worldly symmetries explain exactly? Explanation isn't a trivial relation, right? You don't get it just by being there. The idea that somehow by existing, in some sense, not merely as descriptions, but as pieces of the world, symmetries causally explain particles and properties, physically producing them in some way. Right? I mean, is that what's intended? I'm not really sure what explanation means here. French certainly seems to indicate, at least, that the symmetries are, in some sense, causal. In various places, he contends that the structure of the world, of which symmetry is an aspect, is modal, and that it can be appropriately described in various contexts as causal. So here's a quotation from him, and again, this is on your handout. He says, "We should take laws and symmetries, and hence the structure of which these are features, as inherently or primitively modal." And elsewhere, he says that these laws and symmetries encode the relevant possibilities, and insofar as they are stable or robust under changes to initial conditions, can be regarded as necessary in a certain sense. In this way, the structure of the world can be said to be modally informed. But now I'm having a feeling of deja vu, right? Because that's exactly what the dispositionalists have. Dispositions are powers to behave in particular ways in particular circumstances. They encode those sorts of possibilities. That's what dispositions are. If you press me to give a deeper explanation of what a disposition is, more precisely, I can't really do better than to say, look, it's a primitive of a theory. It's a kind of function that takes you from one state of affairs to another state of affairs. I mean, at this level of ontological depth, it's very difficult to see how either one of these views, the dispositional view or the symmetry-based view, is going to come out looking like the lower fat ontology, right? Like the healthier choice. On the interpretation of symmetries that takes them to be part of the ontology of the world, the natures of properties, I think, don't turn out to be any simpler. Okay, so let me take stock of where we are. The project of giving a dispositional analysis of properties of scientific interest has been challenged in the domain of fundamental physics by philosophers who prefer to analyze properties there simply in terms of certain symmetry principles described by the theory. And what I've been arguing is that the concerns that have been raised about dispositions in this sphere aren't really compelling, and that ultimately the putative advantages of a symmetry-based view turn out to be not particularly advantageous after all. So where does that leave us? I want to close over the next little while by reflecting on what I think is going on here in this debate. I mean, as it happens, I believe that this dialectic between people who like dispositions and people who like symmetries is related to a larger project that I'm working on at the moment concerning different approaches to the metaphysics of science. And it reflects a couple of conflicting stances that have come to really grip contemporary philosophy of science. At the heart of this conflict are different approaches to the nature of explanation. Now, some disputes in this area are, I think, really just not very well formed or ill posed. And as a result, I think some of these disputes about explanation are just philosophically confused. So for example, people who think that patterns or regularities in the world stand in need of some sort of explanation have different explanatory expectations than some people who just are happy with the fact that there are pattern-like or regularity-like things in the world, and that that's just the way the world is, and there's nothing there that requires any further explanation. So some people think that these patterns need some further metaphysical diagnosis or explanation, and some people think that they don't. Right? I see a lot of questions that are begged across that kind of divide by philosophers who really have very different kinds of explanatory aims. But let's say that we share some minimal explanatory aspirations or goals. Many of the people in the debates that I've been discussing today actually think that we should attempt to describe and explain the natures of and the differences between fundamental physical properties, as well as certain relations of causal or modal dependence between them. So symmetry-based theorists, like most philosophers of physics, I think, believe that their approach is closer to the science, that it fits more naturally with physics. And I want to diagnose this by suggesting that it represents a particular stance that you might take towards the outputs of physics. At face value, the standard model describes these invariants of symmetry group transformations, these irreducible representations of the groups. Now, given all of this, right, that's the output of physics, how can we interpret that mathematical formalism so as to give us some kind of knowledge of the world? Well, on the symmetry-based view, the symmetries described by the theory yield a kind of structural explanation. I want to characterize this sort of explanation, or this form of explanation, as top-down, because it starts with the theory and then proceeds from a set of mathematical relations that are described in the theory to yield some insight into the ontological natures of properties. And even though it isn't strictly required by that kind of view, you might even go so far as to endow the mathematical formalism itself with some ontological clout. Right? That's what French does when he reifies them. And locate the modal force of the theory in the laws and the symmetries it describes. And then, the properties can simply emerge as mere descriptions or artifacts, or as sort of conceptual placeholders, or as derivative entities of some kind. So here the causal or the modal content of the theory applies to the world in terms that proceed from the mathematical formalism downward to the natures of properties. And of course I can see the appeal of that kind of approach, right? Not least in an era in which physics and mathematics are so deeply intertwined. And it can be very difficult to extricate the mathematical content from the physical content. And in some cases, it may not even be coherent to think that you can really separate one from the other. Right? That's the top-down approach. On the other hand, some people begin with a philosophical consideration of the ontological character of properties in the world. And one outcome of that kind of reflection is the dispositional view of properties. You can imagine being in an experimental setup and thinking that you have various properties and you want to know how things having those properties are going to behave. If they have this kind of property, they're disposed to behave this way. If they have that kind of property, they're disposed to behave differently. I would characterize that putative form of explanation as bottom-up, because it starts with properties of objects and events and processes in the world, and then proceeds from there to think about how those things are portrayed in mathematical descriptions of them that are given by our best theories. So in this sort of view, one begins by taking seriously these locutions that we find all the time in physics, right? Locutions like, the electron behaves this way or that way because it has properties like charge E or spin 1/2 and so on. That is, you take the because of that locution as indicating that the properties are things that play some substantive roles in determining the behaviors of the particles. It's in virtue of these substantive roles that we think that the properties, right, have some ontological significance in their own right. Now, some people think that the concept of a disposition is kind of alien to science. Perhaps they think that superficially just because the term itself is kind of a philosopher's term, right? It doesn't really crop up in scientific theories. In fact, I heard one philosopher of physics say the other day that neo-Aristotelian philosophy of science is the worst thing to happen to philosophy of science in recent times. It's like a hugely retrograde move, right? This is what he told me. Now, I think that's a mistake. No one, of course, is suggesting that we go all the way back to Aristotle here, right? The disposition is simply a causal or a modal property. It links states of affairs. So whenever we explain some happening in physics or otherwise by citing the properties involved as being responsible, that is, on my own minimal construal, a dispositional explanation. So bottom-up explanations start with the behaviors and things that we can detect, and then regard the mathematical formalism of our best theories simply as our best attempts so far to describe these properties. Now, which one of these stances, the top-down or the bottom-up, is preferable? Well, of course, that's a big question. In some previous work, I defended the dispositional view, in part because I see it as grounded first and foremost in the world of concrete happenings and detections. And that's the world that I think I live in. It's for that sort of reason, I think, that in his book, Representing and Intervening, for those of you who've read Ian Hacking, in that book, he's really much more interested in intervening than in representing. But when it comes to the fundamental ontology of the world, I'm open to the possibility that there may be more than one way to theorize about things. And I want to leave you with the thought that this is actually okay. That even if you want to be a realist about things like subatomic particles and their properties, it's okay to be cautious about their finer-grained ontology. Now, some people would disagree. I mean, some anti-realists, for example, have argued that unless realists can settle on a clear and compelling picture of very fine-grained ontology, that their beliefs in things like subatomic particles will just turn out to be empty. So Van Fraassen, at one point, is famous for saying, unless we can make sense of these fine-grained ontological details, well, then it's time to wave goodbye to metaphysics. And some realists have taken this anti-realist bait, right? They've agreed with this. So yeah, unless we can give an ultimately compelling account of what the fine-grained ontology should be, then our realism is kind of empty. I want to suggest the opposite. Right? I think it's entirely plausible for the realist at one level of metaphysical description to allow for differences at finer-grained levels. And perhaps even to adopt a kind of pragmatic attitude towards different ontological characterizations in contexts where they turn out to be useful. Maybe in the highly theoretical context, the top-down approach is useful. Maybe in an experimental context, the bottom-up approach is useful. While maintaining a realist commitment to the relevant entity or the phenomenon itself. And this, of course, immediately raises a question about whether believing in the existence of an entity, while being kind of easygoing about, or perhaps suspending belief in, or adopting a pragmatic attitude towards its precise ontological character, is a coherent combination of beliefs for the realist. I think that it is a coherent combination of beliefs, and here's why. First, let me say something about the realism part. From a realist perspective, that is, reading the evidence in the way that realists are apt to read the evidence, there's a vast amount of it. Right? There's a vast amount of evidence for belief in subatomic particles. They've been detected in large numbers of experiments. The values and magnitudes of their properties have been measured with tremendous accuracy and precision. They've been causally manipulated in very intricate ways, to such an extent that they've been used to interfere with and to probe the natures of other kinds of entities. Theorizing about these entities has generated novel predictions, which have then been confirmed in subsequent experiments. So these are the very sorts of criteria that realists typically use to justify belief. Okay, so that's the realism part. That seems fairly secure. What about the more easygoing or pragmatist attitude towards the finer-grained ontological detail? Well, while I haven't really made this the focus of my talk today, I just want to leave you with an observation that I tend to characterize most and perhaps even all philosophers of science. While most of these people believe that at least some parts of our best scientific theories are true or approximately true or correspond to the way the world really is, their tolerance for metaphysical or ontological questions really varies enormously. I mean, as we dig deeper and deeper into the finer details of ontology, I think what we find is that most people have a kind of breaking point. A breaking point beyond which they find the questions being asked and the answers being given just too far removed from the actual empirical results of scientific inquiry to be interesting, or perhaps in some cases, so far removed as to be not even worth considering at all. This point, which I readily accept may vary from one person to the next, is the point at which I suggest one should feel free to cross over from full-blown realism into something less committal. Even, why not, into a more pragmatic attitude regarding the ontology and properties of fundamental entities. Thank you very much.
Thank you. Okay, we have a lot of time for questions, so feel free to ask. Is there a microphone I should be using, by the way? And, anyone? No?
So I do have a question, because if I understood you correctly, possibly you have met my breaking point, like metaphysical breaking point at one point when you were telling the story, if I get it right. So, in your attempt in the first part of the talk to defend this positional account against the accusation that symmetries and conservation principles that go with them somehow make the field harder for this positionalists. That's, I think that I sort of had the feeling that it is a compelling argument to some degree, because when you began the story about this position, you said about this. Extremely required.
Sorry?
All right. Okay, so when you began the story about the dispositions, you began with sort of Aristotelian down-to-earth language. So you have this glass of water and a pinch of salt, and the other pinch of salt in a glass of water, it dissolves, and when a massive body is in gravitational field, it falls down. It's like a very natural, intuitive thing in a way of thinking and talking about stuff. So I see the appeal of this story. But then you observe that there are some properties of the universe that are not so easy to explain in terms of these down-to-earth properties. So when you observe that if you add all the water together, the mass of the sum of the water is the same as the mass of the initial glasses. It's kind of surprising, let's say, if you have this bottom-down approach. So you say that maybe we should... So the conservation principle is a kind of tricky thing for a person who thinks in terms of dispositions. And your response is basically, if I get it right, to introduce new kind of stuff into the world. So there's not only like a local small objects, but besides the small object there are things like systems, or maybe the universe, or maybe the population, these kind of new kind of things, and these kind of things also have dispositions, and dispositions of this big kind of massive or collective things explains the behavior of the, for example, that explains the conservation property. And at this point, I guess you might be meeting my breaking point. So I see the intuitive appeal of the initial story, that there's a small object which are disposed to behave this way or the other. But at the point when you say that to save the dispositional of worldview, let's say, I need to buy into I need to overpopulate my metaphysics or ontology with stuff like the universe, the population, the system, which have this or that properties, I kind of start looking around for alternative explanations. If you force me to say this story, you force me into buying this kind of metaphysics, I sort of look around if the Humean has a better way of doing things. That's why I see that it is, and even this realism about symmetries might be more appealing to my eye, because it is a bit like buying into dispositions without buying the objects which these are dispositions of. So in a sense, I buy the symmetry which behaves at least like disposition, but I don't buy that the world is the object that has this disposition. So I stop halfway. Even that is, I suppose, slightly better than going all the way. And I just wonder, what would you say in response to this kind of observation?
Sure, thanks a lot for that. So, if I can recharacterize the terrible thing I've done to you, I think it's not that I've reached your breaking point. I think that I've perhaps articulated the kind of worldview that appeals to you most, right? And you've yourself done a good job of articulating what that worldview is. I guess the onus of my talk here has not been so much to champion one or the other, but to actually show that depending on how you look at these things, depending on how you approach these matters, you may favor one over the other in much the way that you've done. But I don't really see either of these options as being ontologically simpler, more natural, closer to the science, etc. Right? So that was kind of the burden of my argument, to say, look, you can approach it this way, or you can approach it that way. These represent different kinds of ontologies, but I don't think that one scores better with respect to criteria like simplicity. Now, you may be denying that, right? You might want to say, well, actually, no, I think that the symmetry picture is simpler. And I think that, introducing, to use your terminology, overpopulating the world with these other things, right, is something that constitutes a kind of inflation to our ontology. And there I think I want to resist, actually. I want to say, it's not obvious what it means to say that we're overpopulating, as opposed to merely populating the world with things that we need to explain whatever it is that we need to explain. So when you worry, for example, that talking about systems is introducing extra ontological stuff to the world, it's not obvious that it's introducing anything extra if that's what there is in the world, right? I mean, a lot of people talk about the world as though it's the primary thing, right? I mean, some people, monists of various kinds, who think, yeah, there's a world. By positing a world, we're not overpopulating. That's actually the primary thing, and everything else is an abstraction from that thing. Depending on your starting point, I think you're going to regard different kinds of populating as being either excessive or ontologically inflationary or not. So one thing that I would say about the idea of systems per se is that it certainly is positing something that's ontological, that has a kind of ontological cloud over and above the individuals that compose those systems or that make up those systems. Is that simpler than the Humean picture? I'm really not sure. The Humean picture often gets a free ride as being ontologically simple. But if you think about what a regularity is supposed to be, it turns out not to be ontologically lightweight at all. Right? A regularity is an atemporal pattern, past, present, and future kind of thing. Now, what kind of thing is that? I mean, I think if we start to think carefully about what Humean regularities are supposed to be, they're not going to turn out to be ontologically innocent. That's also positing something.
I have the microphone. Don't be afraid. It doesn't bite.
I just have a small suggestion, a terminological suggestion, that if you go to your handout on the bottom of the first page, you are considering a counter-argument against applying or attributing fundamental properties to assemblies or populations. So I think that the distinction, terminological distinction that might be of use here is the distinction between fundamental and foundational properties. That is fundamental, then if you have this distinction, you are naturally expecting that the fundamental would be basic in the ontological sense, atomic maybe or whatever, and simpler, while fundamental might be just those properties that are not reducible. And I think that's Michael Thrabben's distinction. That might be useful here.
Sure, and I'd be happy to call them whatever people will find most clear, and that's certainly the distinction that I have in mind. So the idea is that there are certain properties that just don't seem to be reducible or somehow dissolvable into the properties of things that make up the things that they're properties of. And so if we call them foundational or we call them fundamental, I'm easy actually, so long as we understand that that's what we have in mind.
Yes, but the idea was that the fundamental should be those that are not foundational. So foundational, that if you have this distinction, it's natural to expect that fundamental would be something that is atomic.
While fundamental is not necessarily atomic, it would be it's just irreducible without necessarily being fundamental. So that's the whole idea.
Sure, I think I understand your idea, but I'm not sure I want to characterize it in terms of some things being atomic and other things not, just because what we're calling fundamental here may not be atomic.
Yes, that's the point. So fundamental would be basic and simple. Foundational would be basic and simple, while fundamental might be properties of assemblies without having this idea that, well, they cannot be fundamental because they are not properties that are coming from the basic properties.
Sure. I mean, again, I fully agree with what you're saying. I think we do want to be careful with the terminology here, just because even talk of fundamental, I mean, I use the term fundamental quite a lot. But in this context, we're talking about subatomic particles. It's not clear that they're fundamental. So the use of the term fundamental when we talk about fundamental physics, and the use of the term fundamental when we talk about the most basic stuff, right? They really come apart, because talk about subatomic particles is part of fundamental physics. But if research programs that are being carried out as we speak in quantum gravity come to fruition in certain sorts of ways, then there's going to be something more fundamental than the level of subatomic particles. So I agree with you that the terminology is really important here. You need to specify exactly what it is that I mean when I'm talking about properties of ensembles that give us a kind of explanatory cash value that we don't get from properties of things at a lower level.
If I may have one more question, like maybe returning to your answer, like I sort of see your point, but on the other hand, I see that people who are holists or monists in a way, they sort of also have a moderate ontology, because they don't have the small objects out there. So they also have not that many objects, only the big objects. Let's forget about the small ones. But let's leave this issue aside. Now I want to take your side, just for a change. I wonder what would you have to say about things that were troubling for the standard Humean supervenience kind of guys like David Lewis. They were accused of being too local in a sense, and it was supposed to be problematic because like Lewis wanted to grab all the regularities in the properties of the spatial-temporal points, basically, or objects which occupy spatial-temporal points, and it turns out to be problematic in terms of EPR-like phenomena and particles which behave systematically regular on a distance because of being in an entanglement state. And I sort of see that you would have a story to tell here that would be better than that they had sort of problematic how to explain this kind of regularity. They also, of course, always have this view, say, yeah, that's it. Okay, that's the world works, we don't know why, we'll never know why. But maybe you have a convincing story to say that what kind of object would there be that would have what kind of disposition to explain the behavior of entangled particles in quantum-like experiments?
Sure. Yeah, so let me say one thing first and then address the specific point that you make. I mean, there's always a danger in a talk of this sort, or when we're thinking very broadly about kind of neo-Aristotelian tradition versus the neo-Humean tradition, that those terms carry with them so much baggage that it's not clear what we're opposing to one another. And so here, at least for the most part, I was juxtaposing the sort of neo-Aristotelian conception of properties as powerful, in some sense, with a kind of Humean distaste for that, the very idea of that. Right? But of course, there are other parts of the neo-Humean program, one of them being, for example, Lewis's notion that everything supervenes on local matters of fact. And I didn't have anything very direct to say about that here, although I did, in fact, use the example that we cite as one possible example for suggesting that we shouldn't expect the behaviors of things to be fully explained by the properties of very local matters of fact for precisely the reason that you raised, right? So relations of entanglement might be a really nice example of a system of the property. We have something called entanglement, and there is a kind of holism that applies to that system, such that what happens here will have instantaneous ramifications for what happens here across an arbitrarily distance length, and that might be the nature of that system. And that would be an example. Now, of course, that's an interesting and controversial example, and there are different ways of trying to spell out what's going on in entanglement. But that would be an example of the kind of thing I have in mind when I say that sometimes we need to take system-level properties seriously.
Anyone else? We still have about 20 minutes left. It's a great opportunity to ask a question. And you have to come here.
You didn't use this word, but what is the relation between system-level properties and the idea of emergent properties?
Well, that's an excellent question, and I haven't said anything about it here, in part because I'm a little bit concerned about knowing precisely how to cash out the idea of system-level properties in terms of talk of emergence and reduction. And I think it may depend in part on exactly what we want to describe or what we want to call emergent properties. Certainly the example I gave from Garfinkel is one in which he would like to talk about things being emergent at the level of populations. He thinks that there's something genuinely emergent going on there. I have been a little bit cagey, in part because I think whether we call these things genuinely emergent or not depends on a lot of background as to how we spell out what emergence is. And I haven't really taken a stand on that here. But it's certainly compatible with what I said, that you might think that the best way to make sense of these kinds of properties is as emergent. I imagine other ways of making sense of these things on which they wouldn't count as emergent per se.
I meant a stronger version of emergence. There is emergence is something that has its own causal powers, new causal powers.
Sure, yeah. And so I know the sort of can of worms that will open up. There are new causal powers, and does that mean that those causal powers are in competition with causal powers at lower levels, and so on and so forth? And I don't really have a view as to how these things are going to shake out just yet. So that's something I'd like to certainly think about. It doesn't seem obvious to me that the causal powers are in competition with one another when we look at the specific kinds of cases that I have in mind. And that's taken as evidence by some people to suggest that, well, there isn't anything strongly emergent going on here, right? So that's why I say that depending on how we define what emergence is, it may turn out to be emergent or not. I'm not myself worried about the particular cases I described as engendering problems like Kim's argument for redundancy of causation. You've got causation going on at one level, then you've got causation going on at another level, and it seems to provide a kind of redundancy of causation, and that's problematic. I don't think I see worries of that sort in application of the kinds of cases that I'm considering. But I should consider it some more.
Okay, maybe it's not question so much to comment, but I think that the point of netosphere applied to, well, as a point against your open dispositionality is that you could, well, as far as I get it, the netosphere has got twofold nature. So you can think of it as sort of some, well, as a theorem statement, some real, well, let's say we discover some invariance, that for example the conservation of momentum is linked, and linked, I mean demonstrable from invariance under translations. And then you can think of it in two very different ways. The first is that you can really move things in the world, and then something doesn't change. And this is basically the point, the interpretation you referred to. But there is the second very distinct interpretation that you can think of it as non-existence theorem. Well, that if you translate every single thing in the world by a meter in the same direction, then, well, something is preserved, some quantity is conserved, not because there is some property to the world that there is conservation of this quantity, the quantity that is conserved, but rather that you haven't changed anything. You simply moved the 0 point you simply changed the coordinate system. So this is the same point with the angular momentum and the rotation invariance. So isn't it that, well, so maybe to sum it up, to put my point more clearly, we can think of translations as changes of coordinate system. We see from Nether's theorem that to every invariance of Lagrangian, there is always some change of coordinate system that generates this invariance. So can't we think that the invariant properties that we originally find, like momentum, energy, and so on, are in a sense endangered by Nether's theorem because it only says that we can think of them as a way of invariance of the description of the world, not the invariance of the actions on this world. Not the things that are really preserved, but it points out some superfluous levels in our description. For example, the choice of the 0 point of coordinate system. Thank you.
So, I think that you could attempt, as you say, to think about conservation laws in a much less impressive way than some of the people I've had in mind here that I'm discussing. I suppose rhetorically, from the perspective of the argument that I want to give, I think that would be completely fine, because it turns out that the conservation laws of this sort are just artifacts of what we take to be the genuine laws, then it isn't worrying or something that needs to be accounted for really by either side of this debate. Right? It's only when you do take them seriously as some of the people I described here, as aspects of the structure of the world or something like that, right? That then we have a kind of ontological debate as to how to account for that. So I take your point that there are different ways of reading the import of Noether's theorem, and you can read it in such a way that there's really nothing especially ontologically substantive here that we need to describe, right, in terms of the nature of the properties involved. And if that's the case, and it may well be, right, if you're attracted to that kind of reading of it, then I think that part of the argument just kind of drops out, because then I think there's really nothing at stake between the two sides of the dispute that I'm describing.
Anyone else?
That's a question. That's very simple. Because perhaps I missed something. I think you have a very rich ontology because you speak about things, properties, state of affairs, different kinds of properties. And I have two questions to you. Could you please tell me, what do you think by think? What is think? You know, what kind of object is think? I mean, is this something like a substance in Aristotelian sense, or something else, or the class of properties? Is the first question to clarify the problem. And the second one is a controversy between realism and nominalism regarding the nature of objects. And my question is, what are these dispositional properties. They are universal, or there are something individual. So every object has its own individual dispositional properties. In terms of contemporary ontological language, they are called tropes. So these are my two questions.
Stay here. Stay here and if you have another question, walking up and down.
Okay. Yeah, thank you very much for that. So, if I can take what you said and make two questions out of it, right? There's a question there about the ontology of the kinds of objects or entities that are involved, right? Should we think of them as substances that perhaps exemplify or instantiate properties? Might we think about them instead as bundles of properties of some kind with some sort of relation of compressence holding them together? There are different options, right, for how we might think of these things. And I think that nothing I've said here is telling in one way or the other with respect to which of those views we should adopt. Of course, you might have a preference, right? And I want to say that the same thing applies to trying to think about the finer-grained ontology of the properties I described. So are they universals? If they're universals, are they transcendent universals of a Platonic sort? Are they immanent universals of an Aristotelian sort? Are they instead tropes, right? Abstract particulars? What are they exactly? That again, I think, is a further question one might ask. And nothing I say here really, I think, pushes one in one direction or the other. But I think that those two questions are a really good example of the sort of thing that I was hinting at towards the end when I said that from the perspective of the philosophy of science and other domains within philosophy, there's always a question as to how far one needs to go in clarifying the metaphysics of the kinds of entities that you believe in before you have a substantive enough conception of what they are to make your belief robust, right? And that's part of what I was trying to describe at the end in terms of a breaking point, right? So we have the scientific theory, and it seems to be describing things like electrons and protons, and they seem to have properties like charge and mass, right? And so then one might naturally ask, so what are these things? You say, well, they're entities and they're properties, and I'll tell you a little bit about those categories. And then one might naturally ask, okay, that's fine, but now what are those things, right? What are properties and what are the entities? And then one might start to give accounts of the sort of suggested. You might get even finer with respect to our ontology. And what I was suggesting towards the end was that it's all right from the perspective of a realist at a certain level of description to say, well, enough's enough now, right? That's not to say that there isn't an answer to the question, are these properties universals or are they tropes? It's just to say that it may not be necessary to answer that question, right, in order to be a realist about charge or mass. And that's what I had in mind by saying that at a certain point, you might regard the finer-grained ontological questions as eliciting a debate that doesn't need to be settled in order to justifiably be a realist at another level of description. And I think that in a paper that I wrote recently, I described this as a kind of slippery slope that philosophers of science who are interested in metaphysics inevitably find themselves on. As soon as you start to think about the natures of the entities that are described in scientific theories, one immediately, I think, finds oneself on this slope where you can always persist in asking finer-grained ontological questions. And I suppose the overarching message is that one can be a realist at a certain point along this slope without having to settle all of the debates that follow further on down the slope. And I think this applies not only to realists, but it applies to everyone, right? It applies to empiricists of a certain sort. So if you are the kind of person who thinks that our best scientific theories only describe or only tell us the truth about what's observable, but doesn't really tell us anything about, or it may tell us things about the unobservable world of subatomic particles, but maybe you should suspend belief with respect to those things. You shouldn't believe them. Even if you have that attitude, I think what I'm describing is an apt description of their situation too. They're saying, well, I'm not really willing to go very far down this slope at all. I'm only willing to go as far as observable things. And then, of course, there are finer grained questions about all of the other parts of scientific theory. What makes up these observable things? Is it unobservable atoms and molecules? You might say, I don't need to answer that question in order to be a realist about tables and chairs. So I think that the phenomenon that I'm describing is a very general one that applies to the interpretation of scientific knowledge very broadly.
So your position is simply neutral in these controversies, yes?
Well, in a way, it depends which hat I'm wearing. So in the past, I myself have taken an interest in some of these fine-grained ontological questions, and I've argued on behalf of one side or another. From a kind of metaphilosophical perspective, I can see that there comes a point at which the trade-offs between these different metaphysical views really has something to do with what I hinted at towards the end, and that is the kind of stance one adopts with respect to what kinds of things you think really need to be explained, and what kinds of things would constitute a genuine explanation, as opposed to just, nonsense or hot air. And I think that those kinds of commitments aren't ones that can ultimately be decided because at a certain point they concern matters that aren't really factual. They're sort of matters of commitment about where you think you need to draw the line with respect to explanation and where you think, my world isn't complete until I have this further explanation in terms of something more finite. And I think that choice is really a factual choice. It has to do with the kinds of epistemic stances we bring to the study of it.
Anyone else?
Okay, I have probably a very naive and silly question. So if this is the case, please just say so.
Those are my favorites.
Okay. So I have a question regarding the relation between the symmetry-based approach and the disposition-based approach. Namely, as you said in your talk, the notion of symmetry is defined in terms of transformations that preserve certain properties in general. So it seems to be true, according to this general notion of symmetry, that we are neutral with respect to the question, what is the nature of properties that are preserved in transformations? And it seems to be, at least intuitively true, that those properties that are preserved in transformations might be dispositions, for example, or dispositional in nature. So my general question is, where is the conflict between those two approaches? That's the question. Thank you.
Yeah, I don't think that's a naive question at all. I think ultimately the conflict is going to come between what I describe as a kind of tension between a neo-Aristotelian and a neo-Humean way of understanding what these invariant quantities are, right? And the dispositional way is one that takes these quantities as being inherently powerful, if you like. This is to use what is in, I think, the context of modern science, antiquated terminology, but that's what a disposition is, right? It's kind of causal power. It's something that has the capacity or propensity to confer on the thing that has it certain kinds of behavior. Right? So that sounds like something more ontologically robust than merely saying we have a mathematical description of quantities that are invariant, right, under certain kinds of mathematical operations. It's when you start to take those mathematical operations as descriptive of something in the world that it then becomes less clear whether the things that they are descriptions of are less metaphysically robust or whether they're simpler than a dispositional view. If you take them to be structures in the world that have a kind of primitive modality, right? Perhaps even a primitive causal modality, right? That's the sort of thing that some of the authors I suggested want to say. Well, then now, I'm finding it difficult to tell the difference between the two views. Right? So it depends on how you interpret the mathematics of symmetry.
We still have time for one more question. It's your last chance. Going once, going twice. Okay, sold. Okay, thank you very much, Anjan, for this enlightening talk.
So only shortly, a bunch of practical info. So this was the only lecture that took place in this building and in this room. Right now we will move to the main building, the old one with the huge courtyard inside, and all other sessions will take place over there. We are located on the second floor. Rooms A, B, C and D are on the second floor, and room E is on the ground floor in the corner. You will find information in the main building. So we must go downstairs to the ground floor right now.
Yeah.